So as I said, we'll start by looking at where air leaks in your house. And so again, if you're looking in the winter season, you don't want to see that heat going out into the outdoors. You want to keep the heat inside all winter long. And exactly the opposite in the summer, you want to keep the hot air out of your house. And so we're going to look at a couple things here. We're going to look at where do we find leaks and how do we find them. And we're going to look at how to seal those leaks up. And then we'll look at ventilation as well. Ventilation is kind of the flip side of that, and how well you get air circulating through your home. And so we'll see how all those tie together. Now, we'll look at energy being used in homes, and this is an average value across the United States from the U.S. Energy Information Administration. We looked at a similar graphic to this in weeks prior in some of our previous sessions. We looked at electricity. Now, this is all energy use, whether you're talking about electricity or if you have natural gas heating or something like that. This is all energy use, and this goes back to 2015, but the ideas kind of stay the same. Now, every house is going to be different. Location is going to be different as well. If you look at Florida, you probably have more AC being used. Where farther north you go, you're going to have more space heating. But on average, it's about 43% of your energy use going to heating your home. Right past that is water heating and then air conditioning as well. So that, again, accounts for the heating and cooling systems in your home, account for most of the energy use. And so that's the importance of keeping that heat where it should be, because if you weatherize your house and seal the air leaks, so you're keeping that heat where it should be, then your heating and cooling systems will be more efficient. They will can be designed smaller. You might, if you're replacing a heating system, you might be able to size it a little bit smaller and save some money that way as well. So there's a lot of different ways we can look at energy savings and cost savings associated with this. Now, where air leaks, there's a simple illustration there just showing all the areas. You see some red lines going into the attic. A lot of different ways that heat can get out of your house and into your house, and we'll navigate some of that. But to answer the question I asked earlier, most heat is lost through the floors, walls, and ceilings, so most of the building envelope. And again, every house and location is different, but this is kind of on average. Fireplaces lose air ducts, and we've talked about air ducts and central heating and cooling systems 2 weeks ago. But we'll look at some practicals and where we can look, but this is kind of a general breakdown. Now, at the bottom figure there, photograph, I did include a quick estimate just to give you an idea of the scope and how much these air gaps, we're talking about air leaking and being able to seal any air gaps and cracks that you might have in the house. And I've included this example of a door. And especially with older doors like I have in my home, you'll see, the weather stripping or the seal around the perimeter of the door can leak a lot of air. If it's not sealed properly, you're going to get that air leakage. And so what I did here is a quick estimate of, I think, a 1/4 inch gap around the perimeter of the door, and a 1/4 inch, that's about 1/2 centimeter. So it's not very much space, but just a 1/4 inch gap around the door frame. If you look at the whole top, bottom, left and right of that door frame, if you have that 1/4 inch all the way around, that's about the same size. 58 square inches is about the same size as a dinner plate. And so you imagine the gaps and cracks that you have around that door lets air leak out. And that's about the same as if you were to hold a dinner plate up to your wall, it's that size hole in your wall. And so through that size, you're having air go in and out, and you're losing heat, all winter long through that side of a hole. And so this really adds up, and it can happen through a variety of ways. We'll look at some examples momentarily beyond just doors. We'll look at other examples. But first, I'll just say quickly kind of how to identify those and locate those. You could have a formal energy audit done, and typically many of you are probably familiar with the blower door test if you've had one done or heard about it before. We talked about having energy audits and some of the options in our first session, so you can review that as well. But reach out to your utility provider. They often have services that can connect you with, but in particular, check for the blower door test and contractors that can do that. And what that does is they connect a large fan to pull air out of your house, and they can measure that to find out how tightly sealed your home is. And so they'll give you a CFM, cubic foot per minute rating on the airflow for the newer, tighter homes, typically much smaller flow rates. If you have an older home like mine, my house was built in the early 80s. It's a little bit looser, and so it has a higher flow rate. So that's a formal option there to have an energy audit done. You could do kind of a do-it-yourself assessment as well. A couple options I've included there at the bottom. You could use a draft detector. A fancy way of saying, take a sheet of paper or tissue paper and hold it up to areas around your house. If the tissue paper is blowing in the wind, you probably have air coming through a gap or crack. So you could go around your windows, your doors, and other areas to see if that piece of paper blows. There's also low-cost smoke pins that work just as easy. And the same way, if you see the smoke blowing, you have a draft. And so you want to kind of pinpoint where that's coming from. And then with doors and windows, of course, if you see a gap of light, like I've shown there between the two doors meeting together, that's going to be another source of air leak that you'd want to address. And then additional note here I have for worn out windows. If you have an older window that may be a little loose in its frame, it may be a little wiggly, it may jostle a little bit. There's ways to improve that and get a tighter seal. But it would be an indication that you probably have an air leak in that area. And so those are some of the things you want to be on the lookout for and identify, and then you can take measures to improve that. Now, a couple other areas, places that you might see some air leakage in your home, and I won't go through every one of these in detail, but I'll just point out a few parameters. The top left, for instance, is a view from the basement looking up at the floor. And so what they've done in this case is put some foam insulation and sealant around above the basement foundation. So you have a concrete or brick wall in your basement. That foundation goes right up into the floor of your main living space. And so that's a good area to seal there. So that's one example. In any walls, and not just exterior walls, but especially with walls that you might share with an unconditioned space like your garage. If you don't have heating and cooling in your garage, it's still can still be connected to your living space. And so you want to address those areas first and foremost. Areas in your ceiling would be things like light fixtures. If you have some older non-ICAT fixtures, you might want to replace those, or there's ways to seal around those light fixtures if you know what you're doing. If not, just consult a contractor or someone that knows. But you can get an ICAT rated option with those light fixtures. What ICAT is, it's insulation, contact, and airtight. And so those ICAT rated fixtures give you the benefit of they're airtight, so there's no holes in them. You're not losing air through air leakage, but then the insulation part of it also allows you to put insulation right up adjacent to it. And so we'll talk about insulation a little later this afternoon, but that's one thing you can look for in the ceiling, among other things too, gaps and cracks, more traditional gaps and cracks. Around doors and windows, weather stripping is very useful. Electrical outlets, believe it or not, you can have quite a bit of airflow around those. They do sell gaskets and neat little insulating products for that. If you go through wherever you shop at Walmart or Home Depot, or you can buy different gaskets, or you can use a spray foam like shown in the picture here for that electrical outlet. Don't get it into the electrical box itself, into the enclosure, but around the perimeter of it. There's some options there. On the top right, I've just shown a plumbing pipe coming through the floor, and so you'll see that drainage pipe coming from the bottom of the bathtub, and there's a hole cut into the wood floor, and so that would be something that would need to be sealed. And obviously, if you're renting a home, or if that's already covered up with a finished ceiling below it, if you don't have access from your basement, for instance, it may be a little harder to access that, but What I will say about those areas is, especially when you're working around water, you want to have something that's moisture resistant. We'll talk about some of that a little bit later. Air ducts we talked about 2 weeks ago when we talked about the distribution for heating and cooling systems. You want to make sure the air that's been heated up through your heating system, you want to make sure that goes where it's supposed to go and not leaking out into attics or crawl spaces or basements or something like that. Fireplace can be sealed with various products. And I'm not going to talk about the rest of these. I'll just kind of leave it to you if you want to review this material later, but we'll touch on some of these topics as we go forward through the rest of our program today. Now, again, air ducts is something we talked about, but just to recap from 2 weeks ago, if you have a central heating and cooling system, you have those air ducts running through your house. And a variety of problems can happen with those systems in different areas of the home. Just be on the lookout for that. If you see any leaks or disconnected ducts from the delivery system or return system, you want to make sure that that has been addressed. Okay, so they can be insulated as well. But what I will say is that the two pictures on the right, on the top, you'll see where that duct has become separated and disconnected. Obviously, you don't want your heated or your cooled air just spilling out into a crawl space like that. And in the bottom right, you'll see some small holes in the connection there that you'd want to cover with the mastic. Again, as I said before, you don't want to use duct tape or something temporary like that. You want to put something that's intended for that. And so you can buy the mastic, and we'll look at some examples of that later. Now, there's all types of products that you can use for air sealing, whether it's more traditional caulking, silicone caulking, or spray insulation foam. There's many options. I'm not going to read through this list, but these are some of the most prominent ones that you'll see. What I'll say just on a very general standpoint is the silicone caulking, it'll stretch and compress to some extent, but it's not going to fill large gaps. The traditional caulking is only going to fill maybe a 1/4 inch gap. It's very small spaces. If you're working with a larger gap, you want to use some kind of a spray foam, a polyurethane spray foam or something like that. And that spray foam typically comes in aerosol cans, and it expands and fills the gap. It's not going to fill a huge space, but if you're talking 1/2 inch or more, it may work well with that. And you want to look for any product that you look at. You want to look at the labels. You want to see if you're using it in a moist environment, if it's moisture resistant. So a closed cell foam would be beneficial for a moist environment. A closed cell foam will stop moisture and air infiltration, and also provide some insulation level as well. So that's what you see around the window in the bottom right, is some spray foam that's filled a larger gap with that. So those are some options there, but again, just look at temperature ratings, look at the durability of the product, how many years you could expect out of it. There's a number of parameters to look for, but there's a lot of products out there depending on where you're using it. And so you want to look at the intended use when you're buying a product. Weatherstripping is the other option here for movable parts. So if you're looking at doors and windows that are moving, you're going to need some kind of a sealant, weather stripping for it. There's various foam and rubber options out there. Pictures I've shown are for a tubular rubber weather strip, and then also a door sweep that goes at the bottom of a door. So these are simple, low-cost measures that you can seal those especially larger gaps with, and you can put them all around different components of the windows, and doors as well. So that's something to consider as well. Now, we've talked about sealing the home up. Again, the whole point of this is to keep the temperature where it's supposed to be. The problem is, if your home is sealed too tightly, you're not going to get proper air circulation or ventilation in that room. And newer homes are sealed pretty tight. And so especially we'll talk about like with any kind of fuel burning heating system, you want to make sure those gases don't collect in the environment. But there's a number of issues that I've highlighted here that can happen when you seal your home too tightly. Now, for an older home like mine, I can do a lot of different air sealing around my doors, windows, attic, but I'm still going to have a lot of loose areas. So it's not expected that you'll seal an older home so tight that you end up with these issues. But for any home that is airtight, you will have some of these problems. So mold and mildew, if it's a wet environment. Look at the top left picture there above the shower. You have too much moisture in there. It's not being ventilated and you're getting a moldy roof tiles there. Around windows as well, if you see condensation on the window, you are not removing the moisture fast enough. You're getting that water condensing in the air. It's condensing on the cold window. Carbon monoxide, as well as I mentioned with any combustible device, lower efficiency, improper combustion can lead to carbon monoxide. It's odorless and it's invisible. It's also can result in sickness and can be lethal in high enough concentrations. So there's things to be on the lookout for if you have inefficient, more yellow flames instead of blue, or if you have rust or corrosion on your fuel burning system, you may want to look into the carbon monoxide. But I would recommend for anytime you're doing any kind of a furnace, boiler, wood stove or anything to have a carbon monoxide detector. You'll see that in the bottom picture there. Look kind of like a smoke detector, but it's just reading the carbon monoxide. And there's all kind of smart meters now as well that'll measure carbon monoxide, but since you can't smell it or see it, you need one of those to know if that gas is building up in the house and whether or not you need more ventilation. Other things like radon, again, that's an odorless radioactive gas. It naturally occurs in rocks and soil. You can find it in pretty much everywhere in the country. I have it in my basement, and it requires special mitigation measures. You'll have to have a contractor come out and install a system for that. But again, anytime you seal your house up tight, or even if you've just done some kind of weatherization retrofit, maybe you've made some improvements, go ahead and retest for radon. You can get a kit from your county health department, or you can buy one at a store on Amazon, and you can test your radon. If you have an immediate digital meter, it'll give you instant values. Otherwise, you have to send in to a lab to get your results back. But test for radon for sure. Other contaminants, especially older building materials like lead paint and asbestos, you want to make sure that can get out. If you inhale or ingest any of those types of materials, it can be rather dangerous or lead to lung cancer. If you're doing any kind of work, sanding that paint or anything like that, it can get airborne even more so. And so anytime that you have a closed air sealed environment, you want to make sure you haven't done it too much. And so there is a balance between sealing a home too tightly. You do want to have ventilation in there. Again, it's harder to achieve with an older home just because there's typically so much more air leakage with an older home, but especially be on the lookout for newer homes that are more airtight already. Ventilation can happen in a number of different areas is what I'm showing. A couple ways just to check on your ventilation or to manage your ventilation is just with your simple spot ventilation systems. So here's a kitchen, a range hood over the stove, or a vent above your shower to exhaust some of that moist air, or in the kitchen, you could get rid of the smoke as well through that ventilation system. It's important that those go outside the home and that you're not venting them into the attic or somewhere like that. So we'll address that probably later. But you can have you can have that formal test energy audit done and see what your airflow rate is. The ASHRAE standard for this is for a home is between 0.35 and 1 air changes per hour. ACH is air change per hour. Again, you'd need a professional to evaluate this for you, but that's what you'd aim for is, lower end is 0.35, which essentially means that 35% of the old stale air is exchanged every hour. Okay, and so 0.35 or 35% of your old air is exchanged with new air every hour. And so there are levels for that. A professional contractor could help you with that. They may recommend ventilation systems like a heat recovery ventilator. And so that heats incoming air and ventilates the air that way. So there's other options out there for more or less investment depending on what you're interested in.